In this video, we're going to be talking about how to write an inequality from a graph, table, and verbal expression. By the end of this lesson, you should be able to write linear inequalities in two variables given multiple representations, and you should be able to solve an inequality after writing to verify if your solution is reasonable. We see a lot of situations in the real world that are best represented by inequalities versus an equation. For example, when you are running a fundraiser, the goal of your fundraiser is to take in more money than what is spent because you're trying to donate or give that money away. So to accomplish that, you may need to determine the least number of items that you must sell, or the least number of people that must attend in order to make a profit. And so one way to determine this is by setting up an inequality and solving the inequality to determine what you would need in order to make a profit. When we're writing a linear inequality from a graph, you're going to need to find the slope of the line first, and you'll need to identify another point on the line or the y-intercept, whichever is easiest to spot. And then you'll need to look at where the shading is. So if the shading is above, then you would use a greater than symbol. If the shading is below, then you would use a less than symbol. And then if the line is dashed or solid, so if it's dashed, you will not include the equal to part. If it's solid, then you'll have the equal to part underneath it. And then you'll write your inequality in slope-intercept form or in point-slope form, depending on if you use the y-intercept or a separate point. When you're writing the inequality from a table, you're going to need to find the rate of change. So you'll need to find the change in y over change in x in the table. You'll need to identify the y-intercept, so that's when x is 0. And then you're going to need an outlier. So you're going to need to determine which point in the table does not belong. And so you'll kind of look to see which one changes or disrupts your change in y over change in x. You're not going to be able to determine if the line is dashed or solid from a table. So we're just going to assume that since the values are in the table that it's a solid line. And then you'll write the inequality in slope-intercept form from that. When you're writing from a verbal description, the important thing here is to define your variables and then determine the inequality that you're going to be using. Most of the time when you're writing an inequality from a verbal description, it's going to be written in standard form. But there's a couple instances where it's written in slope-intercept form. So make sure that you're defining the variables, that you're putting them in the right places, and that you have the correct inequality sign. And then you want to make sure that your answer makes sense. So you want to look at how it's set up, and then you want to pick a point or a value, and you want to plug it in and check, does my equation actually make sense for this situation? Okay, so let's look at this graph, the following graph, and let's write the inequality. So from the graph, we're going to need to first identify the slope and the y-intercept. So the slope here, we're looking at change in y over change in x. If I'm picking the 2 points, so the 2 points that they give us, which would be negative 6, 4, and 0, 2. Okay, we would need to find the slope. So we're going to look at change in y over change in x. So my change in my y, I'm going down by 2. The scale is going by 2. So remember that when we're looking at our graph, we need to make sure that we're keeping the scale in mind. So our scale is going by 2. So I go down 2. And then I go right 2, 4, and 6. So that would be 2 over 6 or negative 1/3. So there's my slope, my y-intercept, which is 0, 2. And so now I can begin to write my slope-intercept form inequality. So it's going to be y. I'm not going to put the inequality sign just yet. I'm going to leave that part blank, but I am going to write my slope, which is 1/3 x, and I'm going to put my y-intercept, which is 2. I need to look, is the shading above or below? So the shading is above. So it's going to be a greater than. And then is it going to be greater than, or is it going to be greater than or equal to? I look at my line. So we look at our line is solid, so this would be greater than or equal to. So our inequality for this first one is y is greater than or equal to negative 1/3 x plus 2. For writing from the table, again, we're going to need to find the slope. We're going to need to find the y-intercept. So the y-intercept is easy on this one. They give it to us, so that's 0, 5. What we need to look for is that outlier. So let's start by finding the rate. Let's start by looking at the rate of change in our table. So as I'm looking at the rate of change, I see that from 5 to 2, that's minus 3. From 2 to negative 1, that's minus 3. From negative 1 to 0, that's minus 1. And then from 0 to negative 7, that is minus 7. So I see that my table started to get disrupted right around here. So this is plus 1, this is plus 1, this is plus 1, this is plus 1. So my change happened here. So from negative 1 to 0, this is where my outlier is going to be. So because it didn't go down by 3, I know that this point, this 3, 0 is my outlier here. So we want to kind of keep that in mind. All right. So our outlier is the point in the table that does not match up or does not fit in with the rest of our rate of change. So in this case, my change in y was negative 3. My change in x was positive 1. So that would be negative 3 over 1, which is negative 3. Okay, so now I can begin to write my inequality. So my inequality here is y is, we don't know the sign to use just yet, so y is something, negative 3. X plus 5. And then we're going to use this outlier. So if I were to graph this, right, I would start at plus 5. And then I would go down 3 and right 1. Down 3 and right 1. So here's my line. Remember that we're not going to be able to determine if it's dashed or solid, so we're going to assume that it's solid. And then we have the point 3, 0. So 3, 0 would be over here. So my point 3, 0 would be somewhere over here. And so because it's over in this area, this is on this side right here. And so this would be everything that's above. And so we would have greater than or equal to here. So y is greater than or equal to negative 3x plus 5. So that 3, 0, that outlier part is doesn't help me with graphing the line, but it does help me figure out which side to shade. And so that helps me to figure out which inequality sign I should have here. So in this case, my inequality sign should be greater than or equal to. All right. Here we have an ice cream truck. Can carry at most 75 gallons of ice cream. The table shows the inventory on the truck. Write the inequality that represents the number of gallons of strawberries and banana ice cream on the truck. So we know that at most it can carry 75 gallons. So at most, so less than or equal to 75, because it can't be more than that. And we need to look at what do we already have. So we have x, that represents strawberry, y represents banana, plus what we already have. So that's 15 plus 20, which is 35. And then 35 plus 18, which happens to be 53. And so we have x plus y plus 53 is less than or equal to 75. So this could be this is the inequality that you could write. I can simplify this though. I can subtract 53 on both sides, and I can get x plus y is less than or equal to 22. And so we know for this situation, x plus y is less than or equal to 22. So there are multiple values that this could be, and so because there could be multiple values for x and y, we would just leave this as inequality. Here we want to write an inequality in two variables to represent the following situation. So we have Mary has an interest in music. She loves to buy CDs and cell phone ringtones. Each CDC costs $14, and each ringtone R costs $2, and she has a budget of $56. So if she has a budget of $56, this means that she can spend no more than $56. We know that each CDC, so 14C, plus the ringtones R, which is 2R, must be less than or equal to 56. And so there's your inequality for this one. For looking at the next one, it says Sierra needs to save money. She needs to open up certificates of deposit, which is C, each worth $500. So 500 C. She also needs to save $100 each week, so plus $100 that she saves per week. And she plans to save at least $10,000. So at least means greater than or equal to $10,000. So there would be your inequality here. So this would help you figure out the number of certificates of deposit she would need to open, and the number of the amount that she would need to save, the number of weeks she would need to save. Okay, we want to look to see where the shading should be. So remember that when it's in slope-intercept form, that this tells us where to shade, that we can look at the inequality. This is the only time that we're allowed to look at the inequality to shade, is when it's in slope-intercept, or when it's in slope-intercept form. So here we have y is less than 2x plus 3, so this tells me to shade everything that is below. Here we have y is greater than negative 3 over 2x plus 3, so this says, because it's greater than, this says shade everything that's above. Here we have y is greater than negative 2x plus 5, so because this is greater than, this says shade everything that's above. And this last one we have y is less than 3x minus 2, because it's less than, this says shade everything that is below 1, so everything that is underneath. Okay, before watching the next video, what I would like for you to consider is how we would write an inequality from a table or a graph. As usual, please subscribe to the channel so that you get updates on when new videos are released.